Welcome to my channel about fischertechnik, robotics, Arduino, ESP32 and Raspberry Pi. And this is RaspberryPi2 which runs Raspberry Linux and is connected via a serial network and band cable to this breadboard with some fischertechnik, and not yet to this fischertechnik camera. So the purpose of this experiment is to read the resistance of this photoresistor through a digital to analog converter, analog to digital converter actually, into the Raspberry Pi. If you're new to my channel or haven't subscribed yet, please do so via the thumbnail in the bottom right corner. When starting this Raspberry Pi, I found I had a power issue. So in order to show that and what a possible solution may be, I will continue with the screencast, so I can show everything that you need to see or want to see. As I said, screencast. This is the VNC with a low voltage warning. Check your power supply. I'm going to explain. You can see it here as well, by the way. Under voltage detected. Same thing, low voltage. But why? First of all, I am drawing power via wall socket with a USB converter. Actually, it is meant to charge a tablet or smartphone. Anyway, I'm using it for this. On top is the serial Pi. Serial Pi Plus actually, but doesn't matter. For the serial connection. It draws power for this chip. Next thing, the band cable is connected to this breadboard, which contains this photoresistor as well as the LED as well as the analog to digital converter. It draws power from here. The camera, which is on this tripod, is supposed to go in here, will draw power as well. Altogether, it draws more power than, let's say, the converter, USB converter, is delivering. Solution? I have to put power on here. In comes power adapter, which I also use for other projects, but the point is yet I do not have the same thing right here. So I have to make one. Then connect all the wiring here. So that also means that I can use I can take away these wires from the band cable, put them on these two sockets, and then have the power that way. Much safer, much better for the power anyway. No more under voltage. Question is that doable with the stuff that I have left? Let's see and try. And after a lot of searching for this part, well, a part like that, it finally works, because now I have this AC adapter connected to this breadboard, and although it still says low voltage warning right now, which it didn't say, so while this can't have been then the cause, there must still be something with that. Please check your power supply. Well, I added one, being this one. So, in that perspective, nothing has changed except for, well, power supply here. Oops. So, by the way, now the power for this no longer comes from the Raspberry Pi, as may be clear, because these wires were here, and now it gets from here. Then the analog to digital converter has been disconnected, kind of, because now the output voltage is going straight to here, and I'm not running the program right now. Also, reference voltage is not connected, but I can check anyway if it works out. So let us check and ignore the low voltage warning for now. So Python, and then this one. Does it do anything? No. Still the same error, so I'm not any further. Of course, there is another very interesting question, apart from the fact that I've now connected, obviously, the camera to the Raspberry Pi, as you can see here. But this wire, let me do it this way. This wire is the output voltage. So if I have some voltage from here, I should be measuring it here. When I have the ground probe in here, which is actually ground, you shoot some movement from this voltage needle. And it moves the other way. It should move that way, and it moves this way. You can on the camera barely notice it, but it is visible. So the question is that because of the reference voltage that is not connected, or any other reason? Let's find out via the schematics, because I have here the schematics. This one is connected here, which is of course fischertechnik photoresistor. It gives a voltage. I don't even know what the resistance is right now of this resistor. Port 2 is clock, port 1 is CS0, and if I look right here, then that port of the 8, here's a little indent, which is 1, next is 2, and going back here again, CS0 and clock, so that's not pin out. It's not reference either. So I have to look in that a little bit further. And I found where these two wires should go. They're into place now. Result is now that when I measure either this wire, it does nothing, or I measure on this LED, it does nothing at all. Even worse, when I started the whole thing, oops, and I had nothing connected, this LED was functional via this LED. So whatever the reason, I'm not quite sure, but it did function. And this is output from the Raspberry Pi. Now I can of course run the program again. Which says still 0. Not quite surprising. But it's not what I want to see. Not what I want to experience, not what I want to show. So there is something here that is, well, I'm positive that this is working. This is functional. That one is functional. Is it due to low output? I doubt it. The whole voltage here is functional. I just measured. For instance, here you can clearly see on the multimeter that it is 5 volts, which is excellent. Just why doesn't it give a reference, or why didn't it give me a voltage from this resistor? I don't know yet. And there is some very weird stuff going on actually. All the wiring is now okay. So I have these wires nice where they should be. This wire is where it should be, which is the measured voltage from here. And what happens, or happened rather, is that this LED gave a very bright flash. So unfortunately I had nothing measuring on it. So now here is the plus and this is the minus. And to my surprise also it just measures 1 volt. Just 1 volt. And if I remove this, it disappears. If I remove this, it disappears. So yes, there's 1 volt over it. Over this LED. If I cover this up or go bright on it, nothing changes. So what gives the 5 volts? Or what gives the bright light? Very mysterious. Do I get something when I run the program? No. But I wish. So I should actually change this program that it keeps running while true, and then see that it measures something. But then again, if I'm not looking, I miss it. So once again, a need for a timestamp as well as a log file that I can find it back. Memory short. Anyway, that's the weird thing, and this is the whole setup. And then what happens? This. What I decided to do is move the 5 volts to a different socket, away from the ground. Then, as soon as I put it in, the LED started burning. And it gives 2 volts. So what is the conclusion? Is this working? No, because I don't see anything. I didn't even change the program yet. What does this give? Still 0. Absolute 0. So is this port okay? That's not a question. I changed it from, I think, 15 to no, that's the input, I change the output. I change the output from this. So the real reason that that this is working is because of the 5 volts. However, it gets its voltage from the analog to digital converter, not straight from the voltage from the power supply. So what's the difference? If I pull the plug now, once again, the LED goes off. I put it in, and there it goes. So this is something weird in the circuit, because the program is even running, or is it? It's just measuring. It's sending clock. It should be sending clock and selector and a chip select, but it's not doing it because the program isn't running, and yet this is functioning. But that's something for another time. So with this setup and circuit and results, I thank you for watching. Not what I liked to show, but it is what it is. If you like this, please like this video, give it a thumbs up, subscribe to my channel, leave a comment or suggestion, subscribe via the something on the bottom right corner, and also you can support via PayPal or becoming a patron. More information under this video and in the final segment of this video after this. This is obviously going to be continued. For now, stay safe, have a nice day, take care, bye.